Hello everyone. Today we will start to configure our UART so that we can retarget our printf and scanf statements for debugging purposes. And for that, I will start by creating a new STM32 project. Once the initialization is done, I will select my controller that is Z070RB and I will select the controller. I will name it as UART retarget and make it a C++ project and empty one. Although it is a C++ project I am creating, but for now, I want you to understand the basic concepts of C++ so that we can incorporate it in our complete driver development. For that, I will use this UART retarget as well. And for debugging purpose also, we need to use it. First of all, we need to do some configuration in our project and I will disable the main.c from properties C++ build, exclude resource from build, apply and close. Then I will start by creating a new source file that will be our main.cpp that will contain our header file called as st. We will use the standard library stdio.h and an int main function. So it is the starting point of our application. Then we will go to source and again a new source file. I will separate the uart.cpp file, which will contain all the uart related functions. And also I will create one header file that will contain the prototypes of the uart. So for our other configuration, we will need to add our CMSIS driver over here. So it is a bit complicated for adding CMSIS. I am not sure if it is the correct way. Maybe there might be different way, but I found out this way. So first of all, I will create a new folder in it that I will save it as drivers. In the drivers folder, I will just create another folder, new folder, and I will rename it as CMSIS. In the CMSIS folder, it would be device, new folder, device, and in the device folder, we have our ST. So to include our CMSIS files, I will go to new folder again and advanced option. I will link to alternate for location. Then browse it and I will show you where I take it from. It is in the repos in the STM32 cube. When you come to your user repository, you will have your firmware G0 1.6.2. And here, if you come to drivers and CMSIS, so here you will have to include this folder and finish it. And again in the other device tree here in the ST, again I will go here and create a new folder, advanced, link to alternate folder, browse, then go to the device folder ST and STM32Z0 and include this folder and finish it. So you will see here all the our necessary header files are included. Then we need to add in the properties if we go of the project and in the C++ build, then in the settings, if you go here, you will find that there is GCC compiler configuration. So in the preprocessor, we need to add our controller detail. It would be STM32Z0. Sorry, it will be in caps STM32Z070XX. And the same thing we will add up in the G++ compiler in the preprocessor. If you select, it would come automatically. If this is not coming, you can mention it. Okay, apply and close. For the first time, we need to add our header file, that is has include stm32z0xx dot h. If you press control space, okay, the ID is not helping us here. Okay, let's try to build it. Okay, it's built properly. Then what we need to do is we need to add our function prototypes from the uart.h file. So the function prototypes that we need here is void uart init to initialize our uart. Then we will need void uart, sorry, it will be a uart write function. And another one would be uart read function. That will be a void one. So let's save it and let's include our uart.h file as include uart.h. And here what we need to do is I will copy the prototype functions over there and just erase it, make this functions definitions. So here we will define all our UART functions. First of all, to uh, initialize our UART using CMSIS, we need to enable our GPIO clock and the UART clock. Okay, so before that, how we enable the clocks? First, let us see the dataset and the reference manual. So here is the reference manual that I have already opened. And in the reference manual, if you go down, you go down. Okay, not here. In the data set, if you come to the data set and if you come below, there is block diagram. So in the block diagram, what you need to see, like first of all, you need to know the GPIOs which you need. Okay, so it is given in the reference manual. If you come to memory and bus architecture, and I think it's not here. It should be somewhere here. It's the description page and pinouts and pin description. Okay. So my device is G070RB series, and in that it is uh, 64 pins. Okay. So if you see over here, okay, first let's see the block diagram. Let me show you. Uh, it got, it should be, yeah, here. So see what all uh, buses we have in our Cortex M0 Plus. So it is our AHB bus, that is Advanced High Peripheral Bus, and APB bus is also there. So this is one APB bus, and this is the another APB bus. Then we also have an IO port over here that is connected to our GPIOs, means our GPIOs is connected to our IO port. So like PA 0 to 15 is there, then PB 0 to 15 means like pins are configured like that. Okay. So then we have all our timers, USART, then I2C, SPIs, watchdog, system configuration, then reset and clock control is there. That we will learn about these things in detail in their own respective chapters. But for now, I will show you how you see how you read this data sheet, how you read this block diagram. So the APB bus is having our USART2 and IO port is having our port A. Okay. So to enable our clock access, first come over here and go to reset and clock control. And in the reset and clock control, if you come below, these are the structure. So we have different types of clocks available, like a high-speed internal clock or PLL clock, low-speed external clock that you can connect to 32.768 kilohertz crystal externally. Then we have low-speed internal clock. Also, if you see over here, then here we have RCC registers. Okay, the first register is the control register that is used to clock control. Then we have RCC uh, over here, RCC IOP enable register. So this will enable the input output port that we saw that IO port is over here. So that will once this IO port clock is enabled, then you will be able to access the port A of all the GPI ports connected to IO port. See over here, if you see all the GPIOs are enabled, and then if you come over to GPIO, general purpose input output, and GPIO registers. So since our USART2 is connected to PA2 and PA3, how I know that? That is from the microcontroller Nucleo board. If you see the user manual of the Nucleo board, and if you search USART2 over here, okay, USART, and it's showing USART1 and USART2. Okay, let's search PA2. So here it is connected UART2 transmit, and PA3 here it is connected UART receive. Okay, so you need to configure your COM link device to your microcontroller over PA2 and PA3 for to transmit and UART2 receive. Okay, then if you come over here in the reference manual, and if you see the alternate functions, these things you need to go through every time, like whenever you have to work on the bare metal coding. So if you come over here, you will see that it is connected to our alternate function 1. User2 is transmit is connected to PA2 alternate function 1, and user2 RX is connected to PA3 alternate function 1. So these are the information that you require to initialize your UR2. If you come over here, and this is the mode register that you need to enable to so what is the mode register? So it will it will give the direction of the registers, like input, what we need to what devices we need to attach to our GPIO. Like if I want the GPIO to act as an input port, so I will set and to PA0, for example, I am saying like if I want PA0 to act as an input mode. So what I will do is I will reset I will set the first I will clear the bit over mode 0, and then I will enable like I will set it to input mode. So I will write it 0 and 0, and that is us like software configurable IO mode. Okay. Then similarly, we have alternate function register that is over here, AFRL. And this AFRL register, I showed you over here that our UART is connected to alternate function one, and so we have to set our alternate function register to like AF1. So I have to write like 0001. Or if I have to select like alternate function 4 over here, like I want to enable useart 4 and useart 4 transmit and receive. So over PA0 and PA1, I will be writing. So PA0 will means AF select 0 will select the PA0, and AF select 1 will select PA1. And in that, if I want alternate function 4, so what I will write here is 0100, and also on this pin 0100. Okay. Now we have gathered all the information that we require. I will show you if something misses over here. So now coming to our IDE, let's write our UART function. So let's write RCC colon alternate function register 0. uh, so first of all, okay, let me comment it out what all things we need. First of all, we will need to enable GPIO clock. Then we need to enable our useart clock or uart clock or useart clock. Okay, so to enable GPIO clock, I will go to RCC, and if you hit Control Space, it will show the proposals. Like I am not getting it. I don't know why it's not showing. Let's see once. And we need to add IOP enable register ORing equal to 0x0001. So you can write either like this, or you can write RCC enable IOP enable register uh, ORing, sorry, ORing, and since we have to enable the clock register for GPIO-A, so if we come over to GPIO, sorry, RCC registers and RCC IOP enable register, here it is at the 0th position. So we have to left shift our first bit. Okay. So to you have to left shift our first bit. So 1 left shift by 0. So this is the same output that we will get. Okay. Now we need to enable our UART clock, and that will UART clock is hanging on to our APB1 that we saw in the block diagram over here. In this block diagram, okay, wait, let's go to description. So we have seen that our UART2 is hanging on to the APB bus. So we have to enable the APB bus uh, over here, RCC, means RCC for the APB bus. So if we come to APB enable register 1, so there are two APB buses that is shown over here. See, one is this one and the other bus is this. So if you see, it is the first or second, you have to read in the this register mapping. So user2 is over here, and this is also the RCC APB enable register 1. Let's write it RCC enable APB enable register 1, I'm wondering why it's not working. Okay, let's enable the clock for it for now. So for this, you need to write 0x 20,000. So why I am writing 20,000? And I will show you it in the calculator app. So here, if you come and if you write, see, in the reference and in the data sheet, okay, so it is on the 17th bit position. So we have to write 01 over here to enable our useR2. So for that, if you see the 17th bit, it will show our value to be 20,000 over here. That is why I am taking it uh, as the hex value 20,000. And like writing before the number 0, it is counted as 0. If you write this or this or this, it is the same thing. But writing after the after some value, it will not, it will be a different value. Okay, if you write over here 02, it is the same thing. But if you write over here one more 0, so it would enable some other bit. Like if you see, like it is 20,000, so it is enabled the 17th bit. But like if it is 2 lakh, it will enable the 21st bit. So we need to enable our 17th bit, not our uh, 21st bit. So we will need 5 zeros over here. Okay, the same thing you can use over here, like 1 left shift 17th bit. I will just mention it over here. RCC and PP enable register 1 or in uh, first 1 to the left 17th bit. Okay, so these two are the same things. Now what we need to do is we need to configure the alternate function register over here. Configure alternate function register for PA2 and PA3. PA3 to use our transmit and TX and RX to UART, TX and RX. Okay, so to configure alternate function register, we will go to our data sheet once again, and we will go to our GPIO registers. I think it's over here, and GPIO alternate function register low. And like I showed you over here that in the alternate function mapping, it's over here. Yeah, it's port A alternate function mapping. So user2 and user2 transmit R and receive is connected over AF1. So if we see, first of all, we need to see which where it is connected. So GPIO, we need to for PA2 and PA3, we need to select alternate function 2 and alternate function 3. And over here, we need to write 0001 and 0001. Okay. So for that, I will in the CMSIS library, the alternate function registers are taken as an array because there are two alternate functions. One is the low register and the other one is the high register. So we will program it as like this. We will take the A alternate function register 0 and we will OR it. Then we will do okay. Again, I will show you in the calculator why I am writing that. So, since we have to enable the alternate function select from over here, like the 8th and the 12th one. So, if we write over here on the 12th and write over here at the 8th, we will get the hex values 0x 11,000. Okay, so here we will write 0x1100. Then we will go to we will write for the GPIO. Okay, it's not RCC. I mistakenly wrote it GPIOA. And again, GPIOA is over here. Then we will see that mode register. We have to use over here ampersand, and we will so this would what would this do is it would set the alternate function, and now we need to clear the bit at the mode register. So for clearing a bit, you need to write it like this. It should be F0. I know it because I have gone through the data set, and I will show you why I wrote that once again. So if you come over to mode register, in the mode register, what you will see is like you need to enable it for mode 2 and mode 3. And for that, I will show you again. So here it is the 0, 1, 2, 3, 4, and the fourth and the what fifth, sixth bit. So to do that, we need to write if you see that F0, so it these all will be in the clear bit format, clear bit. It will clear these bits if something is written over there. So we will clear it using F0. So it will clear the bit. Then again, if you come to over here and point to mode register and or it with 0x A0, then it would enable the alternate function for the PA2 and PA3. Okay. Then now we need to configure our useart or Uart, whatever we say it. Means like we are using Uart, not the synchronous one. Synchronous one requires clock configuration. For that, first we need to write our baud rate register. Okay, so let's come over to Uart or useart. So here it is useart, and let's come over to useart register. So in the useart registers, we have baud rate register over here, and baud rate registers like when the UART is enabled, the hardware will auto detect the baud rate. Okay, but we need to write this register. And how I calculate that the baud register that is uh, uh, in the details over here. I will show you that as well. Okay, wait. I will show you how to find the baud rate, how you calculate it. Okay, so use our baud rate generation. So here, if you come over here, then you will see that it is the to obtain 9600 baud rate with use art per cycle. So we will be using at 9600 9600 baud rate, not the 921.6 kilo baud. So these are the examples. You can calculate your baud rate by oversampling and all. So like I will be using it at 16 megahertz, that is 2 into like it is oversampled by 8. So you need to go through this formula, and our baud rate value will be 0x681. Okay. Now coming over to our code, we will write it over the user2 baud rate baud rate register. That we have to write directly. Sorry, equal to 0x0681. Then in the control register, we will enable the receive and the transmit. Okay. So if you come over to control register 1, there are two bit value, that is RE and TE. So it will enable receive and transmit. So receiver is enabled and transmitter is enabled. So this is software written. it clearly says this bit enables the transmitter and this bit enables the receiver of the UART, and it is set and cleared by software. So to enable the receiver and transmitter, I will just simply write it for once, 2 points to control register 1, and that will be equal to 0x00C. So again, that C means what? So C means we are enabling the third and the fourth bit position. So not the third and the fourth according to this. If you compare over here, uh, like it is zeroth, first, second, and third bit. Second and third bit we have to enable. So for that we write 0x00C. Okay. So here I am writing it as 0x00C. Now again use R2. We don't need a control flow. So okay, first of all we need a stop bit. That will be 0x000. Then for the use R2, CR3, it will be 0x000. That is for flow control. And again, now we will write over the user CR1. And in the CR1, we will write at, okay, it's user2 and CR1 0x001. So at the first bit, okay, let's me show you what is at the first bit. So at the 0th bit, not at the first bit, it is the 0th bit. So like if you write over here 1 in this first bit, so it will be 0x0001. So what is happening over here? So it is UART enable bit. So that will enable your bit. Okay, let me add the comment over here, set baud rate, set enable RE and D, receiver and transmitter enabled. Then it would be for one stop bit, then it would be no flow control, and it would be enable user. Okay, now let's try to build it. Let's see. Okay, it's showing some error. It's saying that it's not able to find it. Okay, I have included the file and it's going to this path. No such file or directory we are getting. So what could be the issue? Added this. So it should be enabled over here. Okay, so we are facing this issue over here. Uh, Let me see. So here I have included in the G++ compiler and in the GCC compiler, I've already included both the macros. Okay, so in the include path, we will go to workspace and we will select the driver path that we have included. So we will select once this. The same I will be adding over the G++ compiler and plus and just click it. And again, I will be adding from the workspace itself, and that will be the st include path. And the same path I will be including in the GCC compiler as well. Okay, then apply and close. Rebuild the index, and let's hope it builds correct. Okay, it's building. So that is non-void function written. Okay, that's because I haven't given a return statement over here. Okay, no issues that we will see in a moment. And for this, if you see, I think that should enable the friendly programming. Like ID will help us with the uh, control space. Okay, it's now coming. Yeah, it's now coming. So let's see if US art. Okay, now it's coming. So that was what we need to configure. We need to check it every time. Not every time. Once you have configured it, then you can copy the same project in the next file and just reuse it. And I will just hand it using, okay, so 0x0080 over interrupt and status register of the user. So if you come over here and visit interrupt and status register, so 0x080. So 80 is like you are enabling the seventh bit. Okay, so the seventh bit is TXFNF. Okay, so this is for when you enable the FIFO mode. If you are not enabling the FIFO mode, you have to go status register over here. FIFO mode is disabled. So if you see over here the seventh bit, it is transmit enable. Okay. So since we are writing over the UART, so we have to check it like 0x0080. Or if you are not sure about that value, you can simply write use art2 underscore and then hit control space. Then come to interrupt and status register. It should come. Okay, use art underscore ISR and that is TXE. Okay, so we will be ending with this bit and then it will be an infinite loop and then use our 2 points to transmit data register. So this is another register over here. I will show you use our transmit data register. Okay, it's here. So transmit data register, we will check if it is empty. Okay, we will wait till just transmit data register is empty. Okay, so here if you see, what we will do is just AND it with 0xFF, or if you want it like this, it's okay. It's work. It will work. Then for the UART read function, what we need to do is just we will again test the same condition that it's not true, but this time we won't do this, and I will show you which bit we need to check in the ISR. So it is I guess it is the FIFO mode disabled, and it would be TXE RXE or something. Some bit is there. RE bit, RXNE bit. Okay. So again, we can use that over here. So use art underscore ISR underscore RXNE. If you press it, it will come automatically over here. And then what we need to do is return use art2 read data register. So again, that read data register is over here and receive data register, not the read data register. So receive data value that through UART. Okay. So that is how you configure the UART. Okay. Now coming to our main.cpp. Uh, so for STM32 cube ID, we need to configure one small thing in our project, and that is what like in the main file you need to write uh, one small part of, okay, first let us include our UART file, uart.h file. Just I will sorry, I will just use it over here. So first of all, we need to initialize our UART. Okay. Then we need to set buff over here and std in common null. So we have to set the buffer uh, for the input and the output and std out common null. Okay. So let's test our code over here. And for that, you need to connect your COM port. I am using a generic virtual COM, and that I have connected to my UART pins PA2 and PA3. And my board is connected. And for that, I need, let us write one more thing. Let us write a print statement. Okay, let's write that printf ampersand d. Sorry, not the printf ampersand d, but I will be writing hello world for our testing purpose. And I will write backslash n backslash r to return, and that's it. Let me open my terminal window. I'm using Teraterm as my terminal window. And the serial COM port, I will be selecting Silicon Labs. That is a generic one. You can use it over COM port. And then just press OK. And let's build it. Let's build the target over here. We don't have any warnings or errors. It's successfully built. And what I want is okay, just let us write a delay function that is pseudo delay that we are not returning from here. Okay, or int I equal to 0, I less than, like I will take it for 40,000 or 4 lakh, something like that, so that it's a bit slow. I plus plus, and it's an infinite loop. And here I will take a while one loop. Let's see if it works in the while one, and I will call our pseudo delay function, and let's close it. Okay, so it's done, I guess, and let's build and test our application. So I will just run the UR, and you can set it as default. Press OK. Let's see at our terminal window if it is visible or not. Okay, so in the terminal window, we can come over to serial port and see our configuration. It should be none, one stop bit, parity none, 8-bit, baud is 9600, and it should have come. What could be the mistake that I might be making? Okay, I got the issue. Apart from reading this part of the code, the driver part of the UART, we also need to retarget the read and write function. So where we will find that read and write function is in the source. If you come and syscos.c, here we have two weak functions, that is read and write. Okay, so we will be retargeting this, and here if you see, it is io get char and io put char. So we will retarget it to our uart read and write function. How we do it? Just come to uart.cpp. Here write namespace. Since we are using a C++ application, so we can use namespace std. And in here, like we need to give if def underscore underscore C plus plus, then uh, enter extern C, and in this and if, and in here I will write int underscore write function, or simply I can just go to syscalls and copy this part of the code and paste it over here. And with this, I can simply uh, erase. Sorry, I copied the read part. Okay, it's fine. Let us copy the write part as well. Then we will modify it according to our need. The second function is the write function. So in the read function, in place of IO get char, we can simply use Uart underscore read, and the function should work. And the second thing is, in the write function, we need to pass the pointer in the write function, in our write function, Uart underscore write, Uart underscore write, and in this we will pass the pointer and increment it. And at the end, we are returning length. Okay. And at the end, again, I need to close it uh, as if def underscore C plus plus, and it should work hash and if I expect everything to be fine. And now let's build this target. It is built successfully. Let's run it. So it's verified and downloaded, but it went to the reset handler. I don't think it worked. Like it's in the COM tree, and in here, if you come to the terminal window, in the serial port, so everything is fine, but it is going to the reset handler. It should not work over here. Let's me see once more what I have over ur.cpp. Uh, int underscore read. So I expect it to work, but it's not working. In the main.cpp, we have it. Okay, let me show you how we can debug this, why we are not getting the correct values in the terminal window. So let's start by checking over here, and we will switch to the perspective. So, okay, now we will enter into the, since we are on first using UART init function, we will add a breakpoint over here, and we will, oh, sorry, I just restarted that debugging perspective. And I will just hit this resume button. It will hit that function. Then we can step into this. And here we have special function registers. And in this, like we have to check whichever registers we are using. So for that, like here it has hit the RCC IOP enable register. So in the RCC section, in the microcontroller RCC section, you can come over here and IOP enable register. So we have set it to hit the first bit. So the GPIO-A should be enabled. So let's see if it is enabled or not. Then step into. So we are seeing that GPIO-A is enabled. Now the next is the APB enable register. APB enable register, and let's hit. So we have to check the 17 bit, that is USART2. So it should be again the value should change from 0 to 1. Let's see. And the value is here is the 1. Now let's see GPIO alternate function register 0th index. That means the lower one. We should see that GPIO should be here. Okay, so this is RCC, GPIO-A. Since we are working on PA2 and PA3, it should be here, alternate function register low. Let's see if it hits the correct part. To we have to select second and the third alternate function. Step into. So here we can see that alternate function select 2 and 3 are already working fine. Next, let's see the mode register. Okay, so I missed that mode register. So here comes the mode register, and see, we can see all the registers are 1, and for our purpose, we have to clear the bit for the second and the third mode, third pin. So mode 2 and mode 3, like I skipped, means I pressed the next, so it already cleared the bit. So this is what I meant by clearing. Rest all the values are 0x3, but here you see it's 0x0. Now let's press the next. It should change to alternate function. So this is 0x2 and this is also 0x2. So 0x2 in binary means 1 0. So in the and it is of 2 bit. Mode registers are of 2 bits. So it is like it is set to alternate function. Now stepping the USART to baud rate. So we have kept it 0x683. Let's go to USART2. Let's see our baud rate. I think it should work. This is straightforward. So we are getting it, uh, the correct value. Then control register 1. In the control register 1, we are writing over TE and RE. Then stepping next, control register 2 is 0, control register 3 is 0. And the last, we have to enable the USART. Let's see. This is what is USART2 points to control register 1, and UE, it should turn into 1. Okay, so let's see. It's turned into 1, but it disabled the TE and RE. So can you figure out here what mistake I have done? So the only mistake I see here is, like, if I don't put it, I don't do it an OR operation, it will clear the rest of the bit in the USART CR1. Okay, now I have got it. So you have seen how I debug step by step by seeing into the registers menu. And now again, I will do one thing. I will stop it, and I will again go to the debug perspective. I will switch to the debug perspective and just run it. Enter into the function. Then here, what? Let's see again. let me show you again how I got the issue fixed. IOP enable register is here, and like okay, so it's the RCC register we are checking first. See, in the RCC IOP enable register, it should change into one after this step over. Then again, APB enable register should be changed to the value. The 17-bit should be set to 1 so that user 2 is enabled. Okay, it's done. Now again, if I come over to alternate function register, I guess it should be somewhere here for GPIO A. Where's the GPIO A? Okay, it's here. So in this alternate function register low, we have to select the second and the third alternate function port. Okay, so let's step over or step into. So step over, we see that 2 and 3 are selected. Then step over. And in the mode register, we are enabling the alternate function. Okay, I showed you that mode register. The see second and third bit are 0. Now after this, I'm able to see that it's in the alternate function. Okay. Now the baud rate was correct. CR1 was correct. See, if we come over to UseArt2 and like we see that baud rate is correct and like CR1 is over here and in here like we have to set RE and T receiver and transmitter to 1. Okay, so it's 1 now. And now again, I don't need stop. I need one stop bit, one uh, no flow control. And lastly, we need to enable it. So on pressing next, see, last time it went to 0 and this time it is now UART enable also is turned 1 and our receiver transmitter is turned 1. So that was the problem. And that is how you debug line by line. Okay. If you face any issue in the registers, you can do it as I did now. Now let's give it a complete run. Let me see the main.cpp. I'm calling it one time and I will run it over here and see I got the hello world. Now let me show you how I can continuously run it and I will just move this printf statement over here in the while loop and I will give a delay. Sorry, I will just call the delay function over here and it's like this. Now let us stop the perspective and let us run it. See, it every after a second or something, it would print the hello world. So that is how you debug using the printf in the terminal window. And I showed you how we can debug the complete application if we face some problem that is stepping into one by one in the function. So I put a breakpoint over here and then I did a step in and I found the mistake over here that the UseArt was enabling, but I was writing only to the first bit, not doing a friendly programming over here. And the rest of the bits in the control registers were setting to 0. I hope now you have enjoyed this session and we are able to do UART retargeting for read and write function. From next video, I would give you a brief introduction to all the C++ properties and we'll continue with you guys Hope you are enjoying this and keep me motivated. And I will bring you more interesting stuff in the later videos.